Touch sensor. Sense and detect the touch. Touch it. It senses your touch. Add an LED. It lights up. Let go. Everything resets. No buttons, no mechanical parts. Just your finger and a sensor that knows you're there. This is a capacitive touch sensor, and in this lesson, you'll wire it up, read its values, and use it to control a real output. Every touchscreen around you, your phone, a lift button, a smart home panel, uses capacitive touch technology. The same fundamental principle as the sensor in your hand right now. No physical pressure needed. No mechanical parts to wear out. Just the tiny electrical charge your finger carries, detected the moment you make contact. In robotics, touch sensors are used as triggers. Start a motor, sound an alarm, turn on a light. That's exactly what you'll build today. Here's everything you need. Your Arduino Uno TTP223 touch sensor module. One red LED. Jumper wires, male to male. Your USB programming cable. Your standard breadboard. And your ZAS Sensors Creative Board. To understand how a capacitive touch sensor works, we first need to understand a capacitor. A capacitor is made of two conductive plates with a dielectric material in between them. The dielectric is simply a non-conducting material that sits between the two plates. The capacitive touch sensor works on exactly this principle. Inside the touch sensor, the circular metal plate at the bottom acts as one conductive plate. The PCB itself acts as the dielectric material, and your finger acts as the second conductive plate. When the sensor is powered and you bring your finger close to the pad, a capacitor is formed. The capacitance changes the moment your finger approaches. The IC detects that change in capacitance and sends a high signal through the SIG pin to the Arduino. No touch. The signal stays low and the Arduino reads 0. Touch detected. The signal goes high and the Arduino reads 1. The module has 3 pins. SIG carries the signal to the Arduino. VCC takes 5 volts power. Ground is ground. Left to right, SIG, VCC, ground. Remember this order when connecting. Let's connect the touch sensor first and read its values before we add anything else. The first thing we always do is bring power to the breadboard. This is good practice. Once the rails are powered, every component just connects to the rail rather than running individual wires back to the Arduino. Step 1. Power the breadboard rails. Take a jumper wire and connect the 5 volts pin on the Arduino to the positive horizontal rail on the breadboard. Then take another jumper wire and connect any ground pin on the Arduino to the negative horizontal rail. Your breadboard is now powered. Everything that needs 5 volts connects to the positive rail. Everything that needs ground connects to the negative rail. Step 2. Place the touch sensor on the breadboard. Place the touch sensor module on the breadboard with all 3 pins in separate vertical columns. Step 3. Connect VCC. Connect a jumper wire from the VCC pin column to the positive horizontal rail. The sensor is now drawing its power directly from the rail. Step 4. Connect ground. Connect a jumper wire from the ground pin column to the negative horizontal rail. The ground is now shared through the rail. No need to run a separate wire all the way back to the Arduino. Step 5. Connect SIG to pin 8. Connect a jumper wire from pin 8 on the Arduino to the SIG pin column. Pin 8 will read the high or low signal from the sensor. Open code 1 from Zez GitHub, link in the description. Let's walk through it. Pin 8 is named Touch Pin. Clean and easy to update if needed. Touch Pin is declared as input. The Arduino reads signals coming in from the sensor. Serial.begin 9600 opens the serial monitor so we can see the values live. In loop, digital read reads the sensor every 100 milliseconds. The result, 1 for touched, 0 for not touched, is stored in touch state and printed straight to the serial monitor. Connect your Arduino with the USB cable. Select Arduino Uno under Tools, Board, and your port under Tools, Port. Upload code 1. Open the serial monitor, Tools, Serial Monitor, or Control-Shift-M. Touch the pad. Watch the value jump from 0 to 1 the moment your finger makes contact. Let go. It drops back to 0. That's your Arduino reading a real sensor input in real time. Now let's add the red LED. Keep everything wired exactly as it is. We're just adding 3 more connections. Step 1. Place the red LED. Place the red LED in the breadboard. Longer leg in one vertical column, shorter leg in a separate vertical column. Step 2. Connect pin 9 to the LED. Connect a jumper wire from pin 9 on the Arduino to the vertical column where the longer, positive leg of the LED sits. Step 3. Connect the LED to the GND rail. Connect a jumper wire from the vertical column where the shorter, negative leg of the LED sits to the negative horizontal rail on the breadboard. The rail is already connected to Arduino GND from step 1 earlier, so no extra wire needed back to the Arduino. This is exactly why we power the rails first. Open code 2 from Zest GitHub. Let's look at only what's new compared to code 1. 1 new definition. LED pin set to pin 9. LED pin declared as output. The Arduino sends signals out to the LED. Now the loop has logic. Touch detected. LED turns on. No touch. LED turns off. The serial monitor continues to print the state alongside. Upload code 2. Touch the pad. LED lights up. Let go. LED turns off. Your touch is now controlling a physical output. Sensor input, Arduino logic, physical result, the complete loop working in real time. Now let's move to the Zest Sensors creative board. The red LED is already connected to pin 9. The touch sensor connector is routed to pin 8. Before you plug the touch sensor in, stop and check the pin sequence. Warning: the touch sensor module pins run SIG, VCC, GND from left to right. You must match this exactly to the connector on the creative board. Plugging it in the wrong way could damage the sensor permanently. Double check before connecting. Once you're confident the pins match, plug the sensor in carefully and firmly. Upload code 2, the same code you used on the breadboard. Touch the pad. LED lights up. Let go. LED turns off. Same result, cleaner build. If you face any issues, check the following, or visit the Zest GitHub troubleshooting section, or post your question on the Zest Robotics community. All links are in the description. Here's your challenge. Challenge 1. Add the active buzzer on pin 12. Modify the code so that when you touch the sensor, both the LED and the buzzer activate together. Let go. Both turn off. Challenge 2. Add a green LED on pin 10. When touched, the red LED and buzzer come on. When not touched, the green LED glows. 2 outputs, 1 sensor, opposite behavior. All code and wiring diagrams are on Zest GitHub, link in the description. See you in the next lesson. Visit our website, explore our GitHub, watch tutorials on YouTube, and take your next step into advanced autonomous robotics, starting today. In this advanced robotics journey, you are not alone. You have the support of the strong Zest Robotics community. Follow us.